Welcome to Chaos Engineering from Watermelon. Gartner, in its recent report on digital immunity, calls out the capability to do chaos engineering an integral step in software reliability. Chaos engineering is a controlled method of testing distributed software that deliberately introduces failure and faulty scenarios to verify its resilience in the face of random disruptions. This gives pre-production an invaluable way to test production-like failures before actually releasing software to a situation where customers would experience it. Watermelon gives you the ability to either introduce chaos by journeys or chaos by a part of the journey, which is an application, or simply introduce chaos attacks by platforms. What we are going to see is how Watermelon can take cognizance of the complex infrastructure your application runs on and introduce chaos attacks into that infrastructure, simultaneously executing functional testing scenarios so that the moment anything is injected as a chaos failure, we can see what exactly fails or degrades in the user journey, and Watermelon can tell you what exactly is wrong before it actually hits a customer. Let's have a look at how this is done. So here we are at the landing screen of Watermelon's Chaos dashboard, and let's start by looking at how Watermelon recommends what chaos attacks you need to be running. Now, recommendations can come from the dev side of the SDLC or the ops side. Now think about it this way. When people are setting error budgets or SLOs, you can go ahead and set an SLO for a service, and those SLO breaches would end up as recommendations for chaos attacks. The Chaos dashboard gives you access to various things like observations, resources, which we'll get into. We'll look at schedules, but let's start by looking at the Chaos repository. This is a one-stop shop for all your chaos attacks. And the important thing out here to realize is that you have a dev space, which is called your workspace. And from there, you can publish chaos attacks into a workspace, which is actually accessible to the rest of the users of Watermelon. Unless something is published, it doesn't go into a usable state. So here are some details about a particular chaos attack. You can look at, the various tags, what kind of observations, what kind of resolutions are received. We look at the details of what these observations mean in the later part of the demo, but let's go back and look at the chaos attack itself. You can also go ahead and look at any chaos attack and its previous runs. Essentially, this is a one-stop dashboard into everything. You have this little tag where you can see your favorite attacks and run them again as you need them. This brings us to the point where we'd like to create a chaos attack on a user journey. You can start off here by going ahead and giving a name to your journey. You can give it a little bit of a description, and you can tag your journey with tags that actually help your development cycle. You can also link your journey to user stories that exist in Jira that have been brought in. With that, we now land up at our canvas for creating the journey for the chaos attacks. So a typical journey is, could be anything which a functional tester would test out. We are going to just say that, hey, there is a step one called login, and probably a second step, which could be anything that follows that step, which is, any function that can be tested. Now, at each step, we would go ahead and add a chaos attack. You could start off by defining what platform this step is going to run on. You can see that there are options for AWS, Azure, Kubernetes, OpenShift, and so on. You click, let's say in this case, the VM, where you can then choose the component on which the chaos attack needs to run. You can see a list of available resources to you. We'll talk about it at the end a little bit, how these resources come in. Typically, if you have a ServiceNow CMDB that gets synced automatically, you can also upload these resources through an Excel sheet in a particular format. The ones which are gray are the ones not available to you. Once you do that, you can select the category of attack. You can see that there are different categories like content, failures, stress conditions, and so on. And I'm going to go ahead and create the CPU starvation situation from the category stress conditions. Once I do that, I can go ahead and say what kind of CPU starvation I would like to introduce. And that's pretty much it for the first chaos attack that I would like to introduce into the login step. So you can see that there is a platform that I've chosen under login. The platform is a VM, and then underneath that I've chosen a component, and under the component I've chosen a condition, and finally a situation, a type of attack and a situation. I'm going to go and do that same thing for the second step of the functional test as well, and that will complete our user journey. In this case, I'm introducing a memory starvation into step 2. As you can see, the journey has been saved successfully, which brings us to the next step. This is where you start seeing the power of Watermelon, because you just don't go ahead and create chaos situations, but you can go ahead and set target SLOs for the journey that you just set up during the time a chaos attack runs. So here what we're doing is we're saying that this chaos attack will run one time, and during the time it runs, it has to adhere to an error rate SLA of, let's say, 98%, because that's what your business eventually wants you to hit. They have a tolerance of 2% of failures. Similarly, the response time SLOs is that everything should happen under 2 seconds, 2000 milliseconds. Now, how do I make sure that this happens during the chaos attack? If you are already using functional testing from Watermelon, you can simply go ahead and upload a Watermelon test case, a test pack, if you will. There's a separate section where we can discuss that. Or if you're not, if you're using, let's say, Selenium or Catalan scripts, you can go ahead and import a functional test script at this point to make sure that that runs simultaneously with your chaos attacks. So I'm going to go ahead and do just that, where I'm uploading a test script which has been created by a functional tester to make sure that that runs simultaneously with the situations, the chaos situations that we are injecting. Let's go ahead and upload that. Yep. Now what you'll also find is interesting is that you can go ahead and set your app deck settings right here, which means what we are saying over here is if a step takes less than 3 seconds, call it very satisfactory. If it's more than 4 seconds, call it, tolerating, and anything more than that is a frustrating step. So what happens is that people at the pre-production stage, when you're running production-like failures, have a very good idea then of how a end customer in production would experience this particular user journey when similar attacks happen to them in production. Let's go ahead and see, after saving it, what we can do. Now we set off our chaos attacks. We can either schedule it or execute it right away. We are going to go ahead and execute this chaos attack right away in this example. And remember, while these chaos instances or these situations are being injected, you're also running a functional testing script. So what this means is you're not just going ahead and injecting failures into components, but as you can see, the thing that went green right now was one step of the login that actually executed via the testing script. So you're not just going ahead and saying that, hey, I'm injecting a CPU starvation into X component, but you're doing it with the context of a user journey. You can have a look at what's happening in this cascade view as well, and you can see that one step has been executed in the situation, and the second one, the functional test, is still in progress. So you see that, there you go, that step just got completed, and we're going to go ahead and see whether the chaos tests actually passed. The functional test actually completed, but remember we injected a memory starvation into step 2 for a particular period of time. That I think it's 30 seconds, and the journey now is complete, which enables us to go ahead and now see what exactly happened as a result of this chaos run. We can go to each step, and as a developer or a product owner, you can go ahead and analyze each step of your chaos run. Let's go ahead and look at it, you can see that this passed, but this doesn't really mean anything. You need to go ahead and look at results more at a code level. Yeah. So here are your test case details. This is actually the script that you uploaded at each step of the script, and you can see whether the chaos attack was active while the script was running, because it's possible that the chaos attack itself stopped. You can go ahead and see each step of the script because Watermelon will take a screenshot of the UI where this functional testing is being executed. You can see the duration, what every single step took. And remember, we had set an aptX target for every step. So you can see one of the first step actually took 3.4 seconds. So the aptX score is bad. And the entire chaos script, while it passed, it's also passed more than 2 seconds. So the entire aptX score of the journey is given as frustrating. Every step, one can go ahead and look at the performance as well. Now, this is again a very critical part of shift left in the SDLC, where your reliability targets are moving left towards the design stage. So people can get an idea of how the performance of the code would be under real-world production-like attacks. Finally, let's have a look at what happens after a chaos attack is run. So you can see up here, it says that SLO compliance was partially met, because while the functional tests passed and one of the SLOs was met, the response time SLO was not met, right? And the FD results was okay, but the response time breached the target that we gave it. So right at a pre-production stage, you have the capability of knowing how your actual application journeys would perform in production under production-like failures. Now, what we could do with this is that we could add an observation. Remember, we talked about observations up front. We can add an observation into the system so that the developer side, who's also using Watermelon as a platform to look at, would see what exactly is the results of a chaos test. The execution ID is automatically generated by the system. You have your, you can assign this observation to somebody who will take care of it. You can set a priority to it and give an observation saying that, look, while the functionality is running under this particular memory starvation chaos attack, you had a situation where the performance was failing or breaching the SLOs. So you can add various parameters to it and add that observation. So you can see out here that the observation was added. And of course, the person who it got assigned to can go ahead and pick it up from the observations tab and figure out whether he or she is the right person to deal with it, or reassign it to a developer, because in this case, it's clearly a code issue, right? So they can reassign it to a developer, set the priority to an appropriate limit, and go ahead and add it to the work logs. All work logs, all console logs are going to be part of the system, which can be looked at in an auditable format. And at some point, obviously, you're going to go ahead and resolve the ticket once the issue is solved. Hopefully this demonstration gives you a good idea of how the Watermelon platform can be used, not just for injecting chaos attacks into a component of a application, but also how the chaos attacks can be related to complete user journeys in conjunction with functional tests, giving you a holistic way in which to improve your applications before they end up in production.